One of the things that it's really interesting about going to an asteroid instead of just looking at a meteorite sample on Earth is that meteorite sample has been processed. In other words, it's come through our atmosphere, it has been heated, it has landed on the Earth, it's maybe stayed on the Earth for tens of thousands of years. It's been contaminated in a variety of ways, naturally through erosional processes, wind, water on Earth, maybe even bacteria, other life forms, fungi, and things like that. Going to an asteroid, you can get a very pristine sample, which is very important. Astrobiology really wants that pristine sample. They want to be able to have that contained so they can study and understand all those things that are necessary for understanding how life may have evolved on our planet. In addition to that, one of the things you want to actually have a real sample from a known location is, think of the meteorites that we have on Earth as samples of float. We call it in a geologic term. Right? There are materials that say, in Earth you have a glacier come down from a mountain range and it will spew out all these different types of rock on the surface. You don't really know where that rock came from. You can sort of say, well, this is similar to this mountain range over there, but I don't really know exactly where it came from, what was the locality of that. Going to an asteroid gives you that ground truth. We can actually come back and say, hey, we've had this type of material, we've seen it, it's similar to some of these meteorites. Maybe it's slightly different, maybe it's the same, but we can start making those connections between the types of materials we find on Earth in terms of meteorites and map it back to those asteroids.